All right, number 5. So engineers are designing a box-shaped aquarium with a square bottom. It's an important piece there, and an open top, right? So box shape, so that's a rectangular prism, right? And the aquarium must hold 1,372 cubic feet of water. So it says, what dimensions should they use to create an acceptable aquarium with the least amount of glass? Okay. So what we're going to do is create this box, or at least an image of the box here. And we know that the denominator, or excuse me, the bottom is a square, right? So that means if this is x, then this also has to be x, right? The height could be something different. Like, it doesn't necessarily say anything about the height or the sides to where we know that those are the same. They could be, but not necessarily. Okay. So now they give us the volume, right? And they don't necessarily say the volume, but they talk about the amount of water, and that's usually a volume measurement. They also give us cubic feet, which we know for sure is a unit of volume, right? Cubic length units are volume measurements. And so we know that volume of a rectangular prism is length times width times height, right? And so in this case, it'll just be x times h, right? Or we can write it as x squared h. Okay. And we know the volume is 1372, so we can plug that in here. All right. And the reason I'm doing this is because I want to solve for h. So I'm going to divide both sides by x squared here. And so we'll get h equals 1372 over x squared. Okay. So that's our height. And that the reason I'm doing that is because that's a little foresight, because I know that we're talking about doing our minimizing the amount of glass, right? The least amount of glass. Now, glass is a measurement of surface area, not volume, right? So that's how much area each of the sides are, right? And including the bottom, I'm assuming. And so what we're going to do is we're going to make an equation for surface area, which is all of these faces, right? This face, this face, this face behind here, and then this face over here on the side, right? Okay, and then of course the bottom as well. All right, so the bottom is x times x, right? X squared. We have this square on the bottom here, and so this area is x times x, which is x squared. Okay, and we just have one of those. Then we have these faces, which are x times h, right? And then here we have another x times h, because this is h. And then we have an x times h here on that side, and then we have x times h here. So we actually have 4 of those. So I'm going to put plus 4xh. And remember that what we want to do is get this into one variable. So that's why earlier we did this, right? Because now we can take that value and input it here. Okay, so that's what we're going to do next. So it's going to be s equals x squared plus 4x, and I'm going to put in 1372 over x squared here. All right, and then what happens now when we simplify here is the x, one of those x's and this x cancel out, and so we end up with s. Oops, sorry, keep it the same color. S equals x squared, and then 4 multiplied by 1372 is let's see, 5,488, and then we just have one x on the bottom now, right? All right, so that's our surface area formula in terms of x. And now, since we want to minimize it, we want to take the derivative and set it equal to 0, right? So that's what we're going to do next. So I'm going to take the derivative of this. Okay, so I'll just do, let me make a little line here just to show. So now we're doing something a little different. We're taking the derivative here. So x derivative of x squared is 2x. And the derivative of this, remember that this right here can be thought of as 5,488x to the negative 1 power, right? So I'm multiplying by negative 1, right? So that's going to make this negative, and then it'll be same number, right? Negative 1 times 5,488 is negative 5,488. And then I'm going to take away 1 from the negative 1, which makes it negative 2. So I'm going to get x to the negative 2, and then I'm going to drop it. So it's going to just be x to the positive 2 in the denominator. Okay. All right, so that's the derivative of this function. Okay. So now what I want to do is I want to set that equal to 0 and solve. So it's going to be 0 equals 2x minus 5,488 over x squared. Then what I'm going to do is I'm going to add 5,488 over x squared to both sides. Okay. All right, and that's going to give me 5,488 over x squared equals 2x. Okay, and now what we can do is just, we can either cross multiply or just multiply x squared on both sides, however you want to think of it. These will cancel out then, and we'll just get 5,488 equals 2x cubed, right? X times x squared is x cubed. We can divide by 2. And we get 2,744 equals x cubed. And now we can take the cube root of both sides. Okay, and so these cancel out. And so we get x equals, and then this comes out to 14, the cube root. Now the way to do a cube root on your calculator is you can do math 4, gets you a cube root, and then you just put 2,744 on, underneath. Or you can do a caret, and then you can do 1/3. So you can do 2,744 caret 1/3, and that's the same thing. So anyway, so math 4 or caret 1/3. And both those mean the same thing, and they're both cube roots. All right. And so anyway, we get 14. Now, let's double check this. So this one's a little bit hard. Like if I wanted to take the next derivative of this, it's a little more work. Not too bad actually. So that's kind of, this is kind of where you can kind of decide based on your preference. Do you want to use the first derivative test, second derivative test, etc. So if I take the second derivative of this, that would be s double primed, would be 2, right? That's not too bad. And the second derivative of this would be, remember that we think of this as 5,488 x to the negative 2. So if I multiply negative 5,488 by negative 2, I would get positive 1,000 or 10. What did I get? Yeah, 10,976 all over x cubed, right? Is what we'd end up getting there. And then if I plugged in 14 there, if I did s double primed at 14, you don't have to do all the work, but you know if you cube 14, that's going to stay positive. And if you divide it, a positive by a positive, you get a positive. And if you add 2 to a positive, you get a positive. So we just know that this is going to be greater than 0, right? Which means that it's concave down, or concave up. Since it's greater than 0, it's concave up, which means we have a minimum there, right? So that means this is a min, which is exactly what we want, right? We want the least amount of glass. And they're asking us for dimensions, and so we need the length, the width, and the height. And so we'll plug those in. So we know it's going to be 14 feet x, right? By another 14 feet, which is this other x. So now let's find height. So now let's plug in 1372 over 14 squared. That's going to equal h, right? So we just plug this into our calculator and we get h equals 7. So it turns out that our dimensions are 14 by 14 by 7 feet. And make sure that you tell me which one's which, right? Like having this diagram here shows me that you know like which ones are which, that h is 7 and x is 14. You know, I can kind of get that sense. But otherwise you can say like, you know, the length, the width, and the height, something like that. So make sure you tell me which one's which in that. So those are the dimensions that minimize the amount of glass, right? That would save us cost, but still give us that same volume.